as it relates to GOES satellite imagery and data. You all start out being muted, so there's no unintentional background noise while the panelists are making their presentations. I have a feeling this topic may generate several questions, so if you would, please enter those questions into the GoToWebinar panel, and then I will relay them to the panelists when they are done with the presentations. We also have a member of the social media committee monitoring the social media feeds, and will pass on any questions posed through those specific media. And then also finally at the end of the presentations, you will be able to ask the panelists direct questions by using the raise your hand feature on the GoToWebinar panel, and we can unmute you at that time to ask your question. Okay, it is my pleasure to introduce you today three experts who have spent a lot of time dealing with radio frequency spectrum issues, including the potential effects on interest of NWA members. We have Renee Leduc-Clark, who is founder and principal of Narayan Strategy. She brings nearly 20 years of experience in government and the private sector focused on weather, climate, and aerospace policy, and translating highly complex topics to decision makers. A former civil servant in NOAA, she served in international affairs in both NWS and NESDIS, and later served as a senior advisor to two administrators on satellite policy. She's worked on spectrum issues in the weather community on and off for more than 5 years, and is a member of the American Meteorological Society's Ad Hoc Committee on Radio Frequency Allocations. She also chairs the AMS's International Committee, and she sits on the AMS boards on global strategies and enterprise economic development. Jordan Girth is an associate researcher at NOAA's Cooperative Institute for Meteorological Satellite Studies at the University of Wisconsin's Space Science and Engineering Center. He has a wide range of roles supporting NOAA, from training National Weather Service meteorologists on the next generation of geostationary and polar orbiting satellites, to helping install and maintain satellite tracking antennas on islands in the Pacific Ocean. Jordan has worked with NOAA, AMS, NWA, AGU, and industry stakeholders in submitting comments to the Federal Communications Commission related to a proposal to share spectrum that weather satellites currently use exclusively. And finally, Dave Lubar, who's an electronic engineer. His specialty is radio spectrum management for space systems. He has over 35 years experience, including 15 years directly associated with U.S. meteorological satellites. He currently serves as a spectrum management specialist in the GOES program office. So I'm going to pass it over to Jordan to begin the presentation. Thank you.
Thank you, Frank. For all of you who are joining us for being here today, I think this hopefully you'll find this topic very interesting. Renee and Dave are a great team on this. We approach this issue from many different reaches of the enterprise, as you just heard. Renee from the policy perspective, Dave from the engineering perspective, and hopefully that will provide a very informed presentation on the issues that we're facing with regards to threats to weather satellite imagery rebroadcast. As we move on to the next slide, many of you in the weather community are very much aware that the first United States satellite, GOES 16, next generation, was launched late last year and is soon to be in operations. Early next year, we'll be complementing that with a satellite in the west position as well. And then over the Pacific, our partnership with Japan, they have a very similar instrument serving the Japan Meteorological Agency. All of these satellites not only image the Earth and provide imagery to us, but they also serve a role in data collection. And that's sometimes a lesser known role of these satellites, is really rebroadcasting flood and river gauge information back to emergency managers and other interested parties. We move on to the next slide. We talk about spectrum. Why should you care about it? Well, satellite, radar, and other meteorological systems rely upon radio frequency spectrum to either sense the data or distribute it. With the emerging threats to weather imagery today, we're going to be talking about mainly threats to distributing it. So that is, there's not going to be a change to how the imagery appears, but it's possible that the frequencies that we use to send it around could be interrupted. For satellites, radio spectrum is nearly the only method available to transmit environmental data to Earth. There's no running an Ethernet cable up to GOES 16. The amount of spectrum available is fixed, and adding new users often means interference, because when we share, that means that there's more than one application in any part of the spectrum, and I'm going to get into that in a minute. And interference, the simplest impact of that is it prevents data from reaching the end user. So once there's interference, it's lost. Next slide. Why are we having this issue with spectrum at this time? GOES satellites have used spectrum for many years. The issue is that the amount of internet-enabled mobile phones and the usage of those phones is increasing. This is how internet-enabled mobile phone use looked in July of 2011. And you can see most states between 20 and 30%. But if you move forward to 4 years later, in 2015, you can see there's a lot more smartphone users out there, and there's a lot more demand for high bandwidth data through those smartphones. So for example, people are watching more movies, streaming television, listening to music, etc. with their smartphones. And naturally, as that use grows, the smartphone and telecom companies are looking for more spectrum to serve their users. We move on to the next slide.
Jordan, this is David. Let me interject, please. I think to say hello to the group as well.
Yep.
Just to point out that smartphones are not the only commercial wireless use of spectrum. For example, the Internet of Things proposes to connect billions of devices, home appliances, vehicles, farm animal transponders, all kinds of things into the Internet. All of that requires spectrum.
Yeah, that's a good point, Dave. And as everybody can see here on this slide, that this is how it's divided up currently. And there's many organizations in the Department of Commerce. The National Telecommunications and Information Administration is really responsible for creating this chart here that shows all the different possible types of communications and where those communications occur in the fixed amount of frequency radio spectrum that's out there. And they're color-coded according to the left side. I'm going to zoom in on that third row from the bottom on the next slide here and just show you the very small part of the area where GOES is. So you can see that, well, first of all, where the cell phones are, there's many mobile applications in and around where the GOES-R frequency is currently between 1675 and 1695 right there. And people are wanting to get, commercial users are wanting to get even closer to us. So we are a small part in the economy of sharing all of this spectrum, and there's a lot out there, but it's a very fixed resource, and therefore there's oftentimes a need to share. But we currently use this exclusively. Next slide. Turn it over to Dave.
Take this, and Jordan. These illustrate the downlinks on GOES-R for data distribution or relay. The blue section at the top that calls out the GOES data collection system, the GOES rebroadcast of science and imagery, or GRB as it's better known, and the Emergency Managers Weather Information Network, acronym is MWIM, combined with the High Rate Information Transmission, or HRIT. Those are downlink services from GOES-R. The three white boxes below represent the occupied spectrum for those three services coming down from the satellite and into receivers for users. The orange box on this chart that's labeled broadband, starting at 1695 megahertz, and we'll apologize, but we have to periodically throw out frequencies and frequency terms. That's a new mobile LTE handset transmit band that has not yet been brought into service. It was sold in 2015 at auction. It was limited only to handset use for transmission because of the concern for interference to GOES if they put transmitting cell towers in that band. They were just simply not permitted there. Now let's go over to the other side of the diagram. There's a red box that's labeled broadband and proposed share from 1670 to 1680 megahertz. That's two pieces. The first half has an existing service in it in 1670 to 1675. And that same licensee, Legato Networks, would like to propose to share the second half, 1675 to 1680, which would end up overlapping directly one of the GOES services that you see in this band. It's important because those are cell phone type towers transmitting into devices much higher power. Power here is much higher than planned in that orange block. So it's important to mention that transmitted signals don't always confirm to stay in these neat square boxes like you see here or in the allocation tables. Receivers can also operate over a wider range than just their signal that they want to hear. All these factors are important when we deal with interference.
Great, Dave. Thank you so much for explaining that. We move on to the next slide. Just to summarize here where those central frequencies are, that GRB, which we're going to talk about momentarily, is at 1686.6 megahertz. And remember that shared proposed, the part of the spectrum that was proposed to share was at 1675 to 1680, so very close. MWIN is up there at 1694.1, close to that AWS3 area. And that DCP report relay, that's those flood river gauges and other observations. It's 1679.9 and 1680.2, so very, very close to that. So if we move on to the next slide, you can see here what is the data that's available over GRB. Very simply, that is those 16 bands from the ABI. A lot of the weather community is very familiar with the ABI now. That imagery is sent over GRB to a lot of private sector users and a lot of weather service users as well that are outside of the United States. We'll touch on NOAA Port in a minute for the CONUS users, which is actually also potentially under threat. And also on the GRB feed is the lightning mapper data. If you go on to the next slide here, the GRB is an important source of the full resolution imagery outside of the contiguous United States. There's many industry users here: broadcast television, aviation, energy, ground transportation, other sectors that are weather sensitive. And GRB continues to be the most timely and most reliable source of satellite imagery and lightning products from satellite, GLM. So it's a very important function of the GOES satellite to have that capability to move a lot of high resolution data very quickly to users. Next slide. So if you're a CONUS field office in the National Weather Service, or there's even some private and academic entities that get weather data over NOAA Port or the SBN, Satellite Broadcast Network. That's currently done via SES1. If you were part of the AWIPS Telecon earlier this week, you might have heard about plans to switch that to G28, but the function is essentially the same. If you move on to the next slide, NOAA Port is also a satellite communication mechanism for weather information. There's more than just GOES data on there. Of course, GOES-R and some polar orbiting satellite data flows over that connection. And that's a substantial amount of what is on NOAA Port in the tiled format. There's also a lot of NSEP model output. Essentially anything that goes into AWIPS at a field office, the vast majority of it comes over the SBN. There's also retransmission of the GOES data collection system and the AWIPS workstations are used all across the country and at the FAA Air Road Traffic Control Centers. There's a lot of private sector users. In addition, there's additional third-party channels available from a private sector vendor. So a lot of users that get weather data beyond just satellite data over communication satellite. If we move on.
Let me
go ahead.
Interject for just a second, if I may. This is David. You clearly stated, but there are 4 distinct channels that are carried on NOAA Port from government sources. And as you indicated, it's important to know that not all the GOES are imagery is available. Those tiled imagery data are not the full data set. So there are some people that NOAA Port can meet their needs. There are also private sector entities that provide additional channels that can be received with a NOAA Port receiver on adjacent transponders. So this is the feed for AWIPS. And so if you are at a position handling and making situational awareness decisions by using the AWIPS resources, this spectrum is essential to getting the information to you.
That's a great point, Dave. Thanks. So let's talk about what practically does radio frequency interference look like in imagery. As we move on to the next slide, this is an example from April of 2010 with the previous generation of GOES. You can see very simply on the left side there's large areas that are blocked out from the imagery. There's some lines that come in, some of them don't, and some of them are scrambled or geographically misplaced. As that interference goes away, you can start to see the image again, but that previous image is not resent. Essentially, once it's lost, and because all weather information needs to be timely, we have to move on. So fortunately, this wasn't a situation where there was a need for situational awareness, a wildfire, a thunderstorm, something like that. But you can envision the possible issues if this interference was going on where you're trying to monitor the progress of a fire or storm of some possible damaging weather phenomena. Next slide. This just shows it on a grander scale. A lot of satellite data. The vast majority of data into NWP models comes from weather satellites. It's very difficult to compute things like derived motion winds to get a track of that input data for NWP models on the hemispheric scale. And again, once those lines are through it, it really makes the image difficult to use for those applications, as well as the application of the forecaster sitting on the ops desk trying to issue warnings and things like that. So there's a broad range of impacts related to the loss of data, and sometimes it extends beyond just the lines that are lost, but to the entire image. Next slide. This is a particularly interesting case. So this was from October of 2015, and the interference got so bad that the image that was sent to AWIPS for the forecasters on the left side there kind of stopped halfway through the northern hemisphere. And the issue with it is, if you go on to the next slide, the part of the image that is interesting there is that tropical cyclone, and that's an image that forecasters using AWIPS would have been unable to see because of the gap of the interference that occurred halfway through the image. So losing that imagery is a very tough thing to do, especially when there's systems that need to process it timely, can't necessarily wait or have it resent.
Jordan, I'd like to say, you mentioned when you started these 3 really good examples. This last one is an exceptional example. That's the some of the older style transmission, at least the initial one. I think it's important to note with the new generation downlinks, they're all digital, and they use the same format as that of satellite television. So if you've seen digital television start to degrade, you get a few bad pixels, and then it completely vanishes. That may be more typical of what can happen with GRB or NOAA Port in the presence of really strong interference. So it may not in the future be a case of just having lines to the picture. It may be that you don't have a picture.
Very good point, Dave. Thank you. Moving on. So the proposed sharing in 1675 to 1680, there's a commercial provider petitioned the Federal Communications Commission to share spectrum in that band. And that would be sharing with the GOES-R DCS and very near the GOES-R imagery. And some people say, well, they're adjacent to, but they're not on top of it in the case of the GRB. But what you have to remember is the signal levels could be over 10 million times stronger coming from cell phone towers than those coming from the satellite in space. So, you know, if you live in an apartment building, if your neighbor's having a loud party over there and you're trying to sleep, you could see that it's probably going to be disturbed by that. This is an ongoing issue under consideration by the FCC, and there's been multiple past public comment periods. We've been fortunate to have many objections filed from the diverse stakeholders in the weather enterprise.
Let me chime in there again, Jordan. That was a good summary. You're right. As we pointed out when we showed you the allocation tables, receivers can be wider than the signal of interest, and signals have adjacent band products that spill out. Nothing's as perfect as it's shown on the paper. In this particular instance, there have been no recent public comment activities in this proceeding. It's awaiting a decision by federal regulators on whether or not to move to the next step of the process. So unless the legislative branch would elect to add this band specifically and call it out in future legislation to direct the FCC and NTIA do something, you're waiting then for those regulators to decide when and if they wish to do the next step.
All right. So as it is today, you know, what is the weather enterprise asking for? They're asking for that the delivery of satellite weather imagery always be timely, consistent, and reliable. Those are three things that are very important. We don't have time to wait. Lives and property are on the line. Clients need information, especially when it comes to aircraft. Volcanoes erupt very suddenly and sometimes unexpectedly. We need to get that imagery to the field so that they can get that information to their customers, the public, aviators, whoever that may be. And we believe that the rebroadcast services are a substantial component of that. On the next slide, Himawari 8, I mentioned at the very beginning about the satellite in Japan. It's very similar to GOES-R, GOES-16. So full resolution Himawari 8 satellite imagery is currently provisioned via cloud service, but that we use in some weather service offices, particularly in the weather services Pacific region, Guam and Hawaii. But there's technical access issues and insufficient bandwidth that have compromised the required around-the-clock availability for United States interests. Now, there is also a Himawari cast service that has lesser resolution or degraded resolution imagery that's kind of rebroadcast over a C-band antenna for those, and the Weather Service in Honolulu does receive data from that as an alternate. But that high-resolution data, where you can capture that fine detail that's often needed, is sometimes compromised by a cloud service, which is often proposed as the alternative to using a satellite rebroadcast. And if you go on to the next slide, what we have is... Go ahead.
You make a good point, Jordan, but it's worth noting that Japan elected to drop the direct downlink on the Himawari series when it was built. Their prior satellites did have something similar to HRIT, where you could get it directly from the satellite. Go ahead, Jordan. I think this slide's probably real crucial for you to describe.
Right. So you could see that there's service availability targets for the GOES-R GRB broadcast, and that is the outage allowed over a 30-day window from the GOES-R GRB is only 5 minutes. So that's essentially, we're still within spec if we drop one CONUS frame or 5 mesoscales per month. That's not very much at all. And that gives us a service availability target of 99.988%. And because it's received directly by the using party in most cases, there's no loss of availability as a result of an internet interruption by sending it from the place it's received to the ultimate end user. When you have a cloud service, oftentimes, even if you're using the best of the best like Amazon, there are much less stringent targets. So in the Amazon EC2 service, that's a 20-minute of outage, and that's a service availability target of 99.95%. And when you factor in potential interruptions to the internet, it goes down to 99.93%. For simple storage, they allow even more, 40 minutes, a service availability target of 99.9% per month, and with the internet, that drops to 99.88%. So if you could think about losing internet for periods of time, or losing access to a cloud service for periods of time, sometimes Amazon has failures longer than that, and that can significantly interrupt the flow of data when it could be needed at the most critical times.
I'd like to add to what Jordan said. I'd like to say it in a little different manner because it is so important. GRB has a much higher availability. It has faster delivery, and it's not subject to terrestrial outages of the internet or local power failure. There's nothing between the satellite and the user except for spectrum and their local antenna. When you talk about getting data from a cloud service, or even when you talk about having data processed within a cloud service, let's stop and think about it. You, the user who needs that information, you're probably not sitting right at the output of that cloud service. So what all these numbers boil down to is they have an allocated amount of time in their service agreement that says, I can be out this long and you can't complain. And there's a corollary that says it's going to take me this long to fix it. But the problem is at the end of that cloud service is probably still the internet or local fiber getting it to the user's location. And with power failure, with communication failure, especially in the cases of severe weather, severe flooding, issues that it's the most critical time for a forecaster to have that data, it takes a lot longer than you might think to assure that it's continuous or that it's being restored.
A great point, Dave. Next slide. So the number of users and customers of weather satellite imagery is actually not well known, fixed, or characterized. Certainly, we know about many of the government users, and we know about the big players in the weather enterprise, but because you don't necessarily need a license to receive imagery from GOES-R, it's hard to get in touch with this community because they're not necessarily watching FCC proceedings, and that's part of the reason that we're doing this webinar today, to get the word out that if you are a user or you receive data as part of your weather operations from a GRB system, you may be affected by this, and we're trying to make sure everybody, not only the direct users, the people that own the antennas that capture this and disseminate it, but also the people that then use that data, their customers, are aware of the possible timeliness limitations that would be imposed if the FCC required a sharing of the spectrum that's currently exclusively used.
Jordan, I would like to weigh in on that just a bit as well, specifically on sort of knowing who really our users and customers are, and this is a particularly challenging area, and specifically an area that really our community has been, I would say, inappropriately criticized for. In that some of the one of the companies which wants to share all of this spectrum is like, Well, if you don't know your users, doesn't that indicate that 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 you have a problem as really a commuter? And basically, how is it that you can't know who all of your users are? Well, that is the nature of freely and openly available data, which is something uh, which is really incredibly important and has been established as a value at really the international level. And really this nature of open access to really information is so crucial to really being able to respond to emergency weather situations. And being able to push back on that point is really incredibly important. And yes, of course, I certainly know that NOAA is doing a great deal of work in a lot of different areas, specifically to better identify who those users and customers are. However, in some ways, we're never going to know all of them, and that is the inherent good of how we work with our data.
Yeah, absolutely. I mean, just to put it into perspective, there's a lot of people that come and routinely use the University of Wisconsin pages to get access to satellite data imagery. All of the satellite data imagery that we receive here at SSEC, or I should say the vast majority of it, comes to us from antennas of the rebroadcast that we receive. Next slide. So the weather enterprise must better capture and communicate to regulators and legislators the relative value of these observational data sets for prediction and warning purposes. So hopefully we can communicate to you and you can communicate to others the importance of the timeliness of the data for prediction and warning purposes, and as well as the reliability and availability standards for it.
Let me throw out a couple examples, if I may.
Go ahead.
Renee, go ahead if you'd like.
Okay, yeah, if you could turn back to the previous slide, please. Yeah, this really gets into more of my sort of policy area on really this on this whole issue. And basically, here is the challenge. You know, we work in basically a highly complex area, and specifically, users who use this real-time information directly really have a great deal of technical knowledge and really a great deal of technical complexity in taking a look in really understanding these issues. However, many of the individuals who basically regulate on these topics and specifically make some large decisions on them are not at all aware of really the technical complexity behind our work. And so a lot of what I have been seeking to do in this realm is to really explain these spectrum topics in as simple a way as possible, and to really convey that complexity, really to mitigate some of what really the companies with the various companies who want to do sharing are very quick to sort of dismiss a lot of our technical arguments, saying, oh, you know, there are very few people who actually rely on that. Well, that's not actually true. And we've been making a lot of efforts really to communicate with legislators very, very clearly. One case of that was actually yesterday on Capitol Hill. I was talking to a number of different staffers specifically about the table, which was basically a few slides ago, specifically about the required uptime for these services. Given that it's very easy for basically opposing companies to say, well, we do everything via the cloud. NOAA is investing in the cloud. But the thing is that it's a question of real-time information, and really being able to convey that the cloud works for archival purposes, research purposes, but then when we're talking about real and real-time operations, that is why this real-time information matters so much. And just your run-of-the-mill cloud type of operation is not going to serve those users, and the number of those users is not trivial.
I'd like to give some examples because I think Renee and Jordan have hit it right on the head. Because we find even weather professionals don't understand exactly the role that this plays. So I'm going to just really quickly give you 3 examples that come off the top of my head. One, in the recent flooding in Houston, Texas. As you got later in stages, you had 2 Army Corps of Engineer reservoirs, Addix and Barker, that aren't normally empty, that are used for flood control purposes downstream through the central part of Houston. And as they filled up and the water started to spill out the back of the reservoir and off of the government land, they had to make decisions on whether to release that water down into the flooded Houston area, driving more water down through those areas. All of that information, all of the levels, all of those decisions are based on gauge information that was received solely in 1635 to 1680 through GOES. The other thing that I found interesting, there are a number of private entities in the state of Florida during Irma. After Irma had occurred, they were monitoring a number of the gauges, including one on one of the rivers below Interstate 75, as people were trying to return back to their homes and back through Florida. Any of you who've driven through Florida knows that there aren't a lot of north-south main routes through the state. And they got within, I believe, a foot of the criteria of closing, of making a decision to close Interstate 75 at a time when gasoline was short. People were a lot of people mobile on the roads after it had occurred. And that was due to the fact that there was a gauge below that river reported through GOES. 2 other examples I can think of just real quickly. The mesoscale imagery that Jordan talked about on GOES 16 that's so important is what's being used by the Miami Weather Forecast Office, I believe, to supplement the fact that the FAA weather radar no longer exists in Puerto Rico. Okay, that comes down through GRB. And if you were trying to make situational awareness decisions on that, again, it passes through the spectrum. And last, and one that's probably quite well known, if any of you remember the TV media images during Sandy, when they were reporting the flood levels at Battery Park, as the water levels in New York rose and rose and rose. That's a National Ocean Service gauge reporting through GOES DCS. It passes through this spectrum. So maybe those 3 examples will help you to focus at home a little bit.
Yeah, thank you, Dave. I appreciate that example, and very, very relevant. Next slide. Switching a little bit from the GRB over to the NOAA Port SDN, there's exploratory notice for sharing mid-band spectrum, and that is in that 3.7 to 4.2 gigahertz area. Many commercial companies believe the 3.7 to 4.2 gigahertz is not substantially used since, like the GRB, a license is not required to receive data. This proceeding is in the early information gathering stage, and there's a public reply comment period that ends on November 15th, 2017. There's been a few filings that have discussed the potential impact to users of weather information from NOAA Port or the satellite broadcast network. Next slide. So if you're interested in following these proceedings, many of you are probably not familiar with fcc.gov, which is a bit of a complicated interface, but we've tried to make it easy by providing some tiny URLs to the 2 proceeding dockets there. The left one is not currently taking comments. That's that RM11681 on the 1675 to 1680 megahertz, but you know, these are proceedings are subject to change at any time. On the right side there, that's the 17183. That's the NOAA Port exploratory notice, and that's between the 3.7 and the 4.2 gigahertz. Again, open for replies. If you read a letter that's been submitted and want to reply to it or add information that you believe is missing but should be considered by the FCC, can certainly do that through November 15th by following the that are provided here.
Let me interject a little bit. The process. Go ahead, Renee.
Okay, great. One thing related to the RM11681, which is related to GOES-R, even though it's not currently taking comments because it's not in an active public comment period, it is still an open proceeding. And so if you have if you know of a specific example or some kind of sort of specific story, especially from the recent hurricanes or various recent weather operations, that you feel is a very good point as to why really the FCC should not move forward with spectrum sharing in this area, by all means get in touch with me, and basically we can then work together to then craft that story into something to basically insert into that proceeding. Given that even though the public comment period is not open, there is still plenty of back and forth going on, and basically we know that there are a lot of people who are still looking inside of this proceeding, given that basically FCC has not ruled on it at this time.
That's an excellent point. I was actually going to address, which is a good counterpoint, the right one. And it's just to explain very quickly that we're calling these reply comments. The actual first phase of their comment period ended in early October. So what a reply comment is simply is you look at one of the letters and you reference something said in the first phase, and then you submit pretty much what you want. That is a fairly simple process. And any individual or entity could do that. It's all done via the internet. You can find it on this link. I might mention there were at least 2 entities in the original comment phase that specifically mentioned NOAA Port in their filings, which someone could cite if they were so inclined, and that's the Satellite Industry Association and the Aviation Spectrum Resources Incorporated. So basically that would allow you to participate yourself as an individual or an entity into this right-handed one up into the cutoff for those comments. And then, as Renee said, there's always opportunities by other means and other dialogues to get information out.
And by all means, writing a comment to basically the FCC might seem like a little bit of a strange thing to do, because truthfully, when you look at a number of these letters, they're all written by law firms and use lots of different terminology that you're like, what in the world is this? And truthfully, I have done a lot of work to try to demystify a lot of this process to basically a number of players inside of the weather and water world. And basically, if you have an idea to basically send into the FCC, by all means, let me know, and I'm happy to work with you to just sort of make all the process a lot easier, given that it can seem a little bit overwhelming, given that, yes, we all have day jobs.
All right, great. Next slide.
I can jump right into this one, given that it's related to what I was just saying. Basically, given that I'm a member of really the AMS ad hoc committee on radio frequency, I have worked with a number of different organizations who just like I was saying earlier, had points which they wanted to make. However, they were like, yeah, we don't know anything about all of this FCC process. and so basically, I then worked with really a number of different entities to really help them to get their word out in the most effective way possible. And so during the public comment period, which happened back in 2016, specifically on the GOES-R spectrum issue, we actually had 70 different entities actually weigh in. And some of the response which we got from really the FCC was, wow, we had no idea that folks from this community were going to weigh in so much. And so we really had some very diverse commenters, certainly, and basically recognizing that those who comment inside of these proceedings are strictly non-government entities, given that there's a whole other process specifically for government entities, specifically to comment. And so ranging from companies like AccuWeather and the Weather Company, as well as Schneider Electric, and certainly AMS, and it's the NWA, as well as AGU, but then also WMO, Group on Geo, or Group on Earth Observations, as well as a number of more local organizations. There were some local emergency managers, as well as all of the International Association of Emergency Managers, as well as a number of different ports organizations who rely on DCS information for a lot of their routine port management, such as ports authorities, as well as like barge and tug companies who work on the Great Lakes, and really it was really great to see the wide range of basically entities who were just sort of like, wow, we really do rely on this information, and basically I think that getting all of that word out was extremely important in making the difference. And it's clear that we're going to need to continue to do that type of push, given that there are lots of large moneyed interests that are very invested in wanting to share spectrum and use up as much spectrum as possible. And I would say that the international community is really looking at this, given that on really an international basis, these types of areas of spectrum are used for meteorological purposes across the world. And basically, if the US suddenly allows for sharing inside of this area, it may open other countries to do similar things on really their national level, which would be very much problematic to really the overall interest of particularly the WMO.
All right, we'll move on to the next slide here. As Renee alluded to, some people have had questions about how this all got started. Well, when you share spectrum, you auction that spectrum, and it's a way to essentially, raise money to fund the government. Often, I think the last spectrum auction raised billions of dollars, and the proposal to share the 1675 to 1680 megahertz band actually came from the Obama administration, which had a priority to share, identify, and prospectively share more spectrum. If you move on to the next slide, it is, the prerogative of the Congress, the legislator, to draw up the budget and fund it, accordingly. And they are very interested in looking at ways to raise revenue for the government without raising taxes. So this is going to be an issue that we believe is going to persist for a while. Even if we make it through these initial proceedings, we're going to continue to hear about demand for sharing spectrum because we do have weather satellites that have been operating in this spectrum for a long time, and we believe we're going to continue to need to utilize that spectrum as weather satellite and space communication technology improves, as does the smartphone technology. So with that in mind, We're happy to take your questions. Renee is accessible on Twitter, as am I. Her Twitter handle, or I guess Narayan Strategy's Twitter handle rather, is @NarayanStrategy, all one word. And my Twitter handle is @JJGurth. The easiest way to get in touch. You can also Google my name and send me email if you wish to do that. We have the remaining or the links here once again, and any final comments before we take questions from Dave and Renee?
I'd just like to say that Jordan's last slide was important because the other path besides the regulatory path is these bans can be written into legislation. It's just as effective to communicate with your legislator and indicate to them that this information is important to you and what you do, and that spectrum changes can point that, because oftentimes they don't know. They have no idea this is involved.
Okay, I'll go. I know Trevor from our social media team has been helping us out. Have we gotten any questions through any of our social media for the panel?
Got a whole lot of retweets and likes, but so far I haven't seen any questions, but I'll let you know if I see some or the other.
Okay. Thanks, Trevor. Good. See, now as the moderator, I get to ask questions first then. And my first question is going to kind of go towards Dave, but of course anybody can answer, is, you know, you've pretty much caught all of us up to speed on where we are. What are the next steps as this issue progresses forward?
Okay, well, Frank, we've alluded to it a little bit, but I guess it would be easier to be more specific. In the case of the 1675 to 1680 process, the Federal Communications would have to make a determination that they want to move on to the next step, which would be what they call a notice of proposed rulemaking. They would put all the rules together, the criteria that they think they would do if they wanted to auction the spectrum for sharing, protection criteria for current users. It's highly likely that, similar to the other auction that completed in 2015, they would try to provide some sort of protection by keeping the towers away from certain federal users. It's been our experience in the past that they've ignored private sector users and said, well, you're on your own, which could have some certain significant ramifications for sites like the University of Wisconsin, or like, you know, a commercial meteorological company that was using it for forecast products. For the right one, the one dealing with, it's actually dealing with a much broader set of spectrum. This is very early in the process. And this is what FCC has done in this, NOAA, and the one that involves NOAA Port, has issued what they call a notice of inquiry. So if you go to this link, you're going to see that people are just giving them their ideas and their inputs if they'd like them to do this and what they would do and why they think it's important. So they'll have to go through all those other regulatory steps. Like I said, the only other issue that could force this is there are always broadband spectrum legislations being drafted either by the House or the Senate. And they could very easily write in any of these specific bans and order the FCC within a certain time to make it available. So those are the two paths that could change the purpose and the use for these spectrum bands.
Okay, thank you, Dave. This question is for Renee, although of course anybody on the panel can answer. Is, all right, we've now informed our members, and you know, like me, I'm sure all of a sudden there's some concern about this. What is it specifically? And we've talked about it in bits and pieces throughout the our webinar, but maybe if we could summarize some of the steps that NWA members could take if they are concerned about the issue.
I think we lost Renee.
Yeah,
so
looks like we lost Renee.
Answer, go for it.
I can take that if you'd like. I believe if any member had concerns, Renee offered she would be more than happy to chat with them individually and try to help facilitate it. It is a little intimidating to do the FCC processes, but I've done them over the years in my role in spectrum work. They're not that difficult once you get a hang of it. and it is open anywhere from the individual to companies to law firms. So I mean, it's a wide range and breadth of answers that get done. They do take all of those inputs into consideration, and I think it's very important if someone had a concern, they can raise it with, as was mentioned, the ad hoc committee on frequency allocation at the American Meteorological Society. Actually, all three of us are members of that committee. Get it to Jordan or to Renee, and it can be voiced through also committees here at NWA. The American Geophysical Union, I know they have concerns about some of these things. So there are many paths to get some assistance. It's just important to get the feedback in when they're looking for public comment, because they factor that in before they decide what their next step is. Did that?
Yeah, I appreciate that. Yeah, thank you, Dave. And one thing I want to make known to those on the line and those who might be listening to the recorded version is that if you have any follow-up questions or comments that you think of at any time, please feel free to send them to the Remote Sensing Committee. You can use the emails on the committee webpage, and we'll collect all the questions and concerns and get them to the right folks to help them answer and get the information they need. And I will also be continuously working to make sure that we stay on top of the process and let the membership know what's going on with that. Do we have a question on the line?
Janice?
Frank and everyone. Yeah, this is Janice Bunting, Executive Director of the NWA. I've recently learned that NOAA is going to conduct a study of the spectrum sharing in the 1675 to 1680 megahertz band, which is the GOES band. And I was just wondering, what could our members expect out of that? And would there be any opportunity for them to participate in that study?
Yeah, this is David. Let me take that one. As a result of this overall process and some of the auction revenues, legislation allowed federal agencies to request funds so that they could study the potential of spectrum sharing in certain bands. And NOAA had requested and received funding to look at the 1675 to 1680 band. And they are, in the very, very short immediate future, about to issue a request for proposal for contractors to implement a series of study questions and embark on a 1.5 or 2 year type of effort. And I think as a part of that, you'll find that whoever are the people doing that study on behalf of NOAA will be contacting many people, including members of NWA and meteorological or hydrological organizations. I would strongly, strongly urge you to cooperate with them, because NOAA will then be able to put together officially a story saying, here's how this band is utilized, and answer the type of things that they will be looking for under the terms of that study. I think you'll see that study start very early next year. I think the other actions that we're talking about are absolutely imminent and going to happen any day.
Okay, are there any questions out from our listeners? You're welcome to ask a question now. Use the raise your hand function if you have one. I'm not seeing any at this time. You see anything, Becca?
Nothing. Nope.
Okay.
No questions in the question box either.
All right. Well, we did a perfect job. It is almost exactly 1 hour. Before we leave, I'd like to thank Jordan, Dave, and Renee for taking time out of their day to share with us their expertise in this matter with our members. A few other folks I'd like to thank are Rebecca Mazur and Tricia Palmer of the NWA webinar team, Trevor Boucher of the social media team, Dan Berkowitz and Kim Reed, who are part of the Remote Sensing Committee, and also Executive Director Janice Bunting. All those folks were instrumental in helping to pull this entire effort together, including the webinar. So thanks to all of you. Does there any of our panelists have any final comments?
I would just say thank you for the participants and learning more about this issue. Sometimes when we talk about spectrum, people find other more interesting things to consume their time, but this is an important issue, and I thank the people participating in this call for becoming more informed on it.
I'd like to echo Jordan's sentiments and thank everyone. Yes, the engineering side of this is a little bit esoteric and complex, but certainly has the potential to affect anything from weather broadcaster receiving satellite data on TV or media to a firefighter that is fighting a wildfire and needing information, as well as someone dealing with the effects of flooding and other type things, and the whole gamut in between. It's a whole lot more important than any of us realize, and you know, until the process breaks down and it doesn't work, then we take it for granted that it's fine. Not always the case.
Well, thank you once again, and again, thank the audience one last time. We'll be signing off. This recording will work its way towards our YouTube channels, and thank you again for joining us.